Hi, everyone. Today I'm doing a mock interview with Dan, which we have done before, and I wanted to get into more of the kind of surroundings around what we're trying to go on about system design and machine learning interviews. And so Dan, who needs no introduction, is a general expert in this field, and I think talking to him more about these problems will really kind of open up what things that are really good for interviewing and just general data science as well, right? So Dan, thanks for being here again.
Totally. Yeah, glad to do it.
Yeah. So today I wanted to talk about a kind of recommendations interview question, and so we can kind of dive right into it. But the question is, so let's say that you're basically a machine learning engineer on YouTube, right? And this is your task with basically building the YouTube video recommendation algorithm. How would you go about and start like this process for building it?
Yeah, so I do have the advantage of having heard this question before. And thinking about it, I think it's just such a huge scope. I mean, YouTube with billions of videos, billions of or millions of users and accounts, they certainly have a difficult task ahead of them. How do I recommend the right video to the right user at the right time in the right context?
Yes.
And so I think there's like multiple approaches. There's the idea of, starting, what if YouTube weren't as big as it is right now? And it started small and we had maybe 100 videos and 10 users. And then how do we scale that up to the YouTube of 2020? And I think another approach is like, hey, it's YouTube 2020 and we need to build the recommendation engine from scratch to be able to work across the entire corpus of content on
Yeah.
YouTube. And I think both of those are worthy of discussing and maybe meet in the middle a little bit about the approaches here. But I'm just going to kind of brainstorm the various ideas I have around this. So initially, if you want to do this on a small data set, how would you recommend the right video to the right user? Well, what you can do is you can start with just saying, okay, what do users initially think
Mhm.
about the videos they've seen? So you can see user A saw video number one and watched 100% of it, a 15-minute video, watched all of it. And then user B also watched video number one and watched all of it. Okay, so now we can maybe reason that user A and user B maybe have similar tastes. And so that might be used to predict whether a video that user A watched, perhaps video two, watched in its entirety, now YouTube might recommend that video number two to user B because, well, we've determined that user B is similar to user A
Mhm.
by some model that I can get into in a bit. And we've determined that user A likes video number two. So let's recommend video number two to that paired user. And similarly, if a user doesn't like a video, then another user similar to them, we might not recommend that video to them.
So is this technique the collaborative filtering technique where it's based on
Exactly, yeah.
general neighbors, right? And so
Uh-huh.
the definition as I know it is that users who watch the same thing would likely like the similar types of movies and so or videos, right? So you recommend the same videos that they might have liked, and then users who are
Hmm.
inherently themselves the same, like demographically or something, might like the same videos as well, right? So it's based on activity and then also attributes. Is that right?
Exactly.
Yeah.
Yeah, and you can take a number of features to put into that model of collaborative filtering, user-user collaborative filtering. We could take the demographics of the user, their age and locale, and we could also take what they've been watching, and not only what they've been watching like historically, did they like this video at some point in time, but also weighting more heavily what they've seen recently. And
Gotcha.
I've certainly noticed for myself, if I'm watching a series of videos in one topic, well, guess what? The next video it recommends to me is going to be along that topic.
Gotcha.
And I'm sure there's other features going into that, but I think it's, for the most part, comparing, like for this, fat corner of the recommendation system,
Yeah.
it's going to be comparing, hey, this user liked this other video. and I like the same things this user does, so let's recommend it to them.
Gotcha. Okay.
Um,
So
now
this is
I
on a
am,
sorry. This is on the small scale, right? And so this is like YouTube where it's very beginning, right? And so when you were kind of jumping into it, I guess one thing I wanted to add was how does YouTube then kind of start this prediction algorithm if they don't like have any data to like start out with, right? Because we're assuming that maybe this is like the very first recommendation ever, and so like, can you even show anything, or like basically, how would you ever just show anything at all if you don't really know what any activity from any of the users is in our data set at all?
sure. In most of my experience, the builder of the system is lucky to have, a corpus of data like 100 users have watched these 100 videos. But if
Hmm.
that's not available, perhaps you could use some sort of abstraction or a reference or an approximation that'll be like, well, this is a popular video, or this is a recently released video, or just have some other metric that'll say this is what we're going to start with recommending videos to these users, and then we can shift more towards a user's taste based on how well that initial model performs.
Gotcha.
And you could even use a constantly live updating model to receive feedback as it goes. Say, hey, we predicted this video and we were pretty sure you would like it, but you didn't watch it. Okay, now we're going to update our features of this model, and the next time not recommend a video that we thought you would like for the same reason.
Gotcha. Okay. Cool. Awesome. So the next point that you're going at before I cut you off.
Yeah, so I am a huge fan when building a model like or a system like this to have different models that work together collaboratively as kind of like a symphony, that will say, hey, this model from user collaborative filtering says that you will predict you will like the video, and this other model from item, or like comparing videos to each other rather than comparing users to each other, that will predict that this video is similar to another video that you liked, not comparing across users but comparing across videos, and therefore recommend it to you for that reason.
Okay.
And so that's a completely different parallel, perhaps, vector we could attack on to say, yeah, this video is similar to this other video you've seen based on the features of the video, perhaps the hierarchy of the video's content creator, or the hashtags of the video,
Mhm.
or the release date, or other things like that could be used to compare, even if that video doesn't have many views yet, and we can't compare it to a similar user similar to you.
Gotcha. Okay. So, given this like system, if we were to scale it out, and let's say that we're now focusing the problem on the YouTube of 2020, right?
Hmm.
How would the kind of problem scope change, and how would you like begin to approach the problem? Because
Hmm.
now it's like, let's say that you just joined YouTube, and this is like basically your task with building like the new, YouTube recommendation system plus algorithm. How would you kind of start from that?
Yeah, so I want to be careful with how I present this, because the first thing I want to share is interesting, but not necessarily the final solution.
Okay.
So when initially thinking about this, you take a user feature vector and condense that down to one dimension, and now you have a subset of all the videos on YouTube, and I'll go into more detail on how we construct which videos we'll compare it with. And that subset of videos, we will condense that down into a one dimension matrix vector as well. And so now we have our output, our prediction of, will this single user like, or should they be recommended this single video? We have a one by one multiplication. Now, if we want to scale that out to say, hey, will this single user like any of these videos in an array? If we want to compare it to n videos, now we have that one user times an n length n vectors into now a 2D matrix.
Yeah.
Okay,
For
well,
sure.
now what if we want to speed that up a little bit? We can do comparing a number of users to a number of videos. and that will save us time because now uh, we're multiplying two matrices together once to get the output for a bunch of users and a bunch of videos. But the downside is we still have to perform all those computations. One thing I've found that wasn't initially obvious to me, but I think it's worth experimenting with to measure performance, is that it is using modern day GPUs, or you can use a clever strategy when multiplying these two matrices to get much faster results, at least than I would expect. So multiplying two matrices is faster than doing each operation n times, if that makes sense. It's faster to combine the problem and do it all at once, and you're amortizing the time across all of your users rather than doing it one at a time.
Okay, so I guess taking a step back here, so we're assuming that there are now, let's say, millions of users, right? And then millions of videos now, right? And so I guess
Yeah.
within the frame of the scope is this potentially the problem for where a new user joins the platform and then sees like the YouTube page where they recommended you that like 8x2 like kind of YouTube panel of different videos you can select?
Mhm.
Or is this more like you've watched a video and then you get recommended like another one that auto plays immediately? So I guess in terms of like figuring out the scope, I guess that's probably like first question is which one does that formula kind of apply to, or the matrix multiplication? Yeah.
Yeah, it's going to be more applicable to when you've already seen a video, you've been using YouTube for a while, you're a user who has been, and you have an established corpus of these are the types of videos I like, these are the types of videos I don't like, don't interact with, and therefore you're able to construct a not quite unique or a distinct 1D user vector. So that
Gotcha.
way we can actually save time by combining many users who have also spent a lot of time on YouTube. And now we're saying, okay, for user A, do they like video X? For user B, do they like video Y? And doing it all at the same time. The opposite side of that problem of we got a bunch of new users and most of them don't have a lot of, they haven't generated the data for YouTube. YouTube doesn't know quite yet what kind of videos they like. That's, I'd say, a different kind of problem because then you don't have so much data. So what you could is recommend them videos that new users tend to like, or you could just say, hey, these are the most popular videos across all of them. That's maybe good enough. I think those are different approaches, but they don't solve the same meat of the problem as what I'm suggesting of combining multiple users and multiple videos in order to amortize your time to perform one calculation. It's a huge calculation. You're multiplying some pretty big matrices, but you're saving time by not doing it one by one.
Gotcha. So does that mean that each user then gets bucketed into like a bigger group of users that has that like similar preferences so we can reduce the dimension, or is it
Aha. So that's the next thing I want to get into,
sure.
the what I'll call more of a final solution, because in this initial case, we're assuming we can't bucket things yet. It's just saying, hey, we have some raw data. Bucketing is not an easy problem. So maybe we could iteratively then add bucketing to this as another vector of attack.
Okay.
If our first formulations were user-user collaborative filtering, and our second component of this multi-level model is item-item collaborative filtering, and then the third generation technique I want to point out is what you mentioned, reducing dimensionality of cardinality of the user vector.
Okay.
So you can perform perhaps unsupervised k-means clustering to say, hey, this is the type of user that likes videos about movies, and this is the type of user that likes videos about sports, and you can cluster them into two separate buckets, similar on a lower dimensional space than the entire user vector. Similarly, actually, it turns out you can reduce the cardinality on and map onto the same domain the feature vector of the videos, of the items that you're classifying. So that way you can actually take the proximity of a user to a video without having to compare it to any additional models. Each user outputs is now reduced to a lower dimension that is on the same space as the item or as the video, and therefore you can compute the distance and you can compute the likelihood of that this user will like this video just based on distance. It becomes a little more complicated when you want to take into account recency of other videos they've seen. If I'm watching a lot of, silly, funny compilations or whatever, then it'll be more likely to suggest that one next. So it might take a time displaced series of, oh, yesterday Dan liked these kind of videos and today he likes these kind of videos. So this is how we're going to weight them differently in the sorting algorithm.
Okay. So I guess going back there, because I think I got lost for a bit. When you're thinking about the dimensionality, is this basically reducing a person's like users or features into like some sort of vector, kind of in the way that like word2vec works in natural language processing, where you take like a sentence or a word and you like basically reduce it into like the similarity between different words? Or is it more so just taking like a or like, I guess, like, yeah, is that kind of a similar idea there?
Yeah, it's definitely a similar idea. I'm hesitant to compare them directly, just because word2vec is there's a lot to unpack there,
Yeah.
and I'm sure it contains a lot of things that I'm overlooking. But it's just so not only are we reducing cardinality, is kind of a bonus of this process. The main thing I want to get at is that we're mapping the user vector and the item vector onto the same space so that they can be compared directly just using a Cartesian distance formula.
Gotcha. Okay. That makes sense. That makes more sense, I think. And so what would make them, I guess, comparably similar, and what would make them like comparably distant from each other? What would affect them, I guess? Yeah.
It would be completely tastes of the user and categorization of the item. Just to back up a little bit, I thought of an example. So I think comparing this to word2vec would be similar to mapping a word in one language to a vec that maps to the same space as the same word in a different language. And you can compare whether or not they are indeed the same word by comparing the proximity of those two words onto the word2vec mapped space.
Gotcha.
If that makes sense.
Okay.
Yeah.
So
So now rolling forward, can you remind me again what your ask is, your question?
oh yeah. So basically, now that we've gone this kind of like general comparison, are we kind of like finalized? Are we using that as like the final way to compute? Would it scale towards the fact of like working for like all these users that have new videos loading up? Would it work for our algorithm, I guess, also in terms of YouTube's like kind of like goal as well, in terms of producing the best content for the user? Are there any other considerations that we have to take into place, or just general edge cases that might come up?
Yeah, there's 2 or 3 that specifically come to mind. So first of all, this is that the reduction I've done. I've certainly simplified it. There's a lot of edge cases that come up as you performing this. One that comes to mind is what you mentioned about a new user. Like, we don't have a lot of data on this person. How do we generate content, or how do we recommend content for them?
Yep.
But one of the biggest problems in my mind is, how do you do this on a billion videos? You can't really map a billion videos onto a Cartesian plane and another several hundred million user profiles onto that same plane, and then try to do nearest neighbor algorithms. That's not going to scale very well.
Yep.
So one thing you could do, and there's many ways to do this, is filtering what videos get generated as candidates to even be possibly put into this real-time function. I want to get recommendations now. So
Yep.
I'll say, okay, well, this video is about sports. Is sports even remotely close to this user's profile? And if so, then okay, we'll put the bucket of sports videos that hopefully we conveniently have somewhere accessible by hierarchy.
Hmm.
That map is going to be super complicated, but I think that could be the way to do it. And now once we've filtered, not only do we have a domain of sports videos, let's say, we could even filter. I understand that just random selection has performed quite well in generating the recommendations for any system. Let's continue relating it to YouTube. So if we just randomly sample the newest sports videos that have been released on YouTube in the past 6 hours and plug a portion of those into our model, then we're going to get some pretty good results in a lot better time than if we put the entire library in or perform an initial calculation uh, on request load. Just reducing that sample size is going to be crucial for getting this to be performance at all.
Okay. And so let's assume that we have like these videos also tagged, right? Like I know users can tag these videos as sports. Um, there's probably like a channel classifier as well, where we classify each
Mm-hmm.
person's channel into like several categories as well. And so we have all these like vectors floating around, right? And so once we filtered it down in terms of the recommendation, how do we decide, I guess, what other features do we care about um, in terms of bringing forward like the newest video, like because I know like we don't want any like
Mm.
random sports video, right? Like if I upload a picture, like a video of my niece hitting a baseball, obviously that probably won't be like what
Mm-hmm.
people want for like most of their recommendations, right? And so I'm assuming that there has to be some sort of like general heuristic tier also when it comes to recommending like the next video that is
Mm-hmm.
maybe built off of a model or just built off of general like kind of heuristics.
Yeah. So that was exactly the very next thing I was going to mention. So I would recommend doing this in two layers, having a first initial pass filter that will say, hey, from the entire corpus of videos of billions, we're going to select, say, maybe 100 or 200 that match the requirements we're looking for.
Hmm.
And maybe those 100 to 200 will include that video of your niece hitting the baseball, and maybe it'll include uh, the currently trending video that is much more likely to actually get bubbled up onto the user's queue. But we're
Hmm.
going to return them both just the same at the end of this initial pass filter. Maybe we'll attach scores to it, but that's not so necessary because the second filter, the second layer in this model, will be what we'll call a ranking model, and that'll be more rigorous and use the same techniques that I've mentioned before, but it'll be a much lower corpus, so you'll be able to perform the more intense calculations and perform them in amount of time on a much lower number of videos, 100 or 200. And then it can say, okay, now we have these 100 videos, let's cut maybe 50 of them from the list at all. And then the next 50, we can actually attach a number to them so they can easily be sorted, where that number is the likelihood that you will watch the video. And something I actually learned while poking around is that YouTube apparently wants to not necessarily maximize the top videos it recommends. I understand it doesn't want to necessarily maximize the likelihood that you'll like the video, but it wants to maximize your time spent watching the video.
Mm.
So if you have a 15-minute video and a 5-minute video, it knows you'll like the 5-minute video more, but you'll probably watch them both in its entirety. It'll bubble up that 15-minute video higher up the queue.
Yep.
And I understand a lot of YouTube content creators are, or had been, I don't know, complaining about longer videos get bubbled up on YouTube's algorithm more frequently. Well, it does specifically on that ranking step, as I understand it, but not in the filtering step. So sure, it'll be recommended to you, even if it's a short video, but it'll just be much lower down the queue.
Gotcha. That makes a lot of sense, and I think it kind of brings up more of why YouTube is trying to push content, because I think uh, is there some sort of then metric in which they are finding that like the more videos or the longer amount of time that you spend watching a video, the longer that you might stay on the platform for or come back to the
Hmm.
platform later. I'm not entirely sure if that's the case, but that kind of makes sense for how much money YouTube could make over time. Given that, if it only recommended like 10-second like TikTok videos, then maybe you're gonna quit after like 10 videos versus like one long video that's 20 minutes, right?
Exactly, exactly. It's a measure. It's one metric for engagement. And if it's a longer video, you might be more likely to, if you're engaged with it, to subscribe to the channel or watch an ad or two. And I think that's what YouTube seems to be interested in.
Gotcha. Okay. So we've talked a little bit about like the algorithms that are needed. We talked a little bit about kind of like how it could scale by like filtering out some of these videos that would next come up. I guess the last part I want to mention is how would we then measure the success of the new algorithm that whatever we would build, and like I guess what is the optimal algorithm also that we would probably implement that could really scale out well, specifically, and then also be able to measure our impact on the YouTube recommendation.
Hmm. So that sounds like a mostly classic A/B test example. You could have a control that experiences maybe weights heavily one portion of the model, or just throws out the model completely and just recommends the most viewed videos, as opposed to the ones similar to what it thinks you will like.
Hmm.
And then compare the results. Does your model at least perform better than average? Now, in terms of optimizing the model, and I would encourage this, even if you're not asking, is this model, did we do a good job? I think this would be part of a final implementation, would be constantly self-updating. It would introduce random noise and say, hey, we're going to weight this feature more heavily. How did we do? And one thing you could use as a metric for how did we do is comparing to a control group, which group moved the bottom line, the thing you're trying to measure most in the ranking algorithm the most.
Yep.
And if that is amount of time spent watching videos, then that's a relatively simple metric to watch. For the users in our control group, how much time they spend watching videos. For the users outside, how much time do they spend watching videos. And similarly, you could have a weighted learning algorithm as part of the different features, perhaps within layers of the model, or perhaps between layers of the model. And that I mean how to weight the different layers. And you could introduce random noise there and say, hey, if we weight this maybe 50% more on this, turn this knob 50% more and turn this down 25%, how did we do? And if that improves it, then that's a signal to, hey, go in that direction. And it'll constantly be learning, not only, it'll be between models and within models.
Gotcha. Okay. So a lot of it, because of the scale of YouTube, it seems like there has to be a lot of just general adjustments, and then also getting that feedback into like changing the actual algorithm, right?
Yeah.
So is this process isn't just like ever like set in stone, right? It's like probably almost always changing at some like every day of the week, like every single new day is like it's constantly updating its feeds in terms of like tuning
Hmm.
toward what we're trying to optimize. Is that correct?
I wouldn't discretize it so much as like once a day or once every few days. I would I would say this, like, in a busy loop, just optimize the models as much as you can. Say, hey, for the last few minutes, how did we do? And as soon as you finish computing that and generating new weights, do the next few minutes and just constantly have it live updating. And it does make the service a little more brittle, but I think that's the way to get the best possible output. And if you are thinking about changing a fundamental part of the model, perhaps adding a new layer or removing a layer or changing the learning weights, then I would recommend doing that much slower, perhaps on the order of once a month, dare I say.
Yeah,
And because those are heavier changes, and I feel like those should be done with more caution. But the initial design should be evolving, should be live evolving.
gotcha. Okay, cool. Um, is there anything else that you think we should add before we kind of like end this part of the interview?
Two more things that come to mind. One, is that so this very complex system, uh, it's a lot to lay out, and there's a lot of places it could
Yeah.
break. And like imagine, I believe this has happened in the past year or so, that YouTube's recommendation algorithm completely breaks. Nothing can talk to it. It's borked. You can't fix it in the next 5 minutes either. It's going to be
Yeah.
down for at least an hour. You don't want to be able to. You don't want to have to discard all of your potential recommendations. So if you're going to be building this in real life, I would really recommend having a fallback or two to say, hey, if this doesn't work, this fancy thing, let's fall back to this more basic thing about maybe just using one layer of the model and then ship that off, good to go. And and then if that breaks, you could have an even further fallback to just say, hey, recommend more videos off that same user's channel, and also recommend the most viewed videos of the day. And that seems a lot more robust to me. It's not going to be as powerful, but it's going to be a lot more stable in the case of catastrophe.
Yeah, that makes sense.
Yeah.
Yeah.
And one more thing I wanted to bring up is, so it's my understanding that, a lot of business putting a lot of videos on YouTube, and they want to understand the business metrics behind what makes this video more viewed than this other video. And when you have the simple item-to-item collaborative filtering or user-to-user collaborative filtering, I'll call those simple relatively anyway. It's a lot more easy. It's a lot easier to determine, oh, the reason this video is popular is because it doesn't have any ads, or for specific features. It's a lot easier to pull those out and to say, this is why this video is performing better than this other video. But it's my understanding that the second you reduce the cardinality of these feature vectors for both user and item, yes, it's a lot easier and faster to compare these things in terms of Cartesian proximity, but you lose the ability to, tell your clients, your customers, this is why this video is performing better than this other video. So that's why perhaps an ensemble would be able to perform this job better for YouTube. Perhaps it's not as accurate, but you still retain the ability to tell customers, we like this video because it had bright colors and you were talking the whole time, or specific features that you're
Mhm.
able to still pull out before reducing cardinality. Just another point I wanted to touch on: might be right in the right circumstances and wrong in the other circumstances.
Yeah, I guess for YouTube, what would you think they would care about in terms of the complexity slash interpretability trade-off?
You know, I think they'd want to retain some level of interpretability for their internal sources. But I don't know how frequently they're actually talking to businesses and telling and advising them this is why they like this video more. I would think that it would be sufficient to be able to say, hey, this is a video that was popular, this is a video that was not, and the content creator will will find the patterns for themselves.
Gotcha.
And because I mean, it's their own content, so they should be familiar with it and be able to determine, oh, it's because we use bright colors, or oh, it's because we kept this video, you know, highly engaged with the user in terms of speech patterns. But I definitely see how it's value to internally be able to know why one video is boosted over the other. So for that reason, I would favor the cardinality reduction. It's going to have a lot more performance. It's going to be a lot more stable. And I think it's going to yield better results.
Gotcha. Cool. I think we'll end it there. In terms of, do you want to do like overview or retrospective feedback as well, actually? I think that might be helpful.
Yeah, that sounds great.
Yeah. What did you think about the question in general, I guess? Well, I know you had some predisposed a look at it as well.
When I first saw the question, I was like, oh crap, I don't know as much as I would like to about this. I hope I can give a coherent talk.
Yeah.
And then I, spent some time yesterday doing some research, and I feel like I got a much better grasp on it, like filling in the gaps, at least from my perspective, on what I could talk about. I think it's a great question and very topical, because a lot of people wonder, like, how does this work? And I tried to make what I talked about technical but not prohibitive for someone who hasn't delved into the space so deeply. And I am hoping that anyone could take specific points to pull away and say, oh yeah, I didn't think of that,
Yeah.
or contradict me perhaps if they have a better idea than I did.
Yeah.
So I think it's a great space, and it has very broad scope, which is why we were able to nitpick, say, hey, let's focus on this area of the problem, focus on this area of the problem.
Definitely. I think that was good. I think the scope is really big. So I think it's hard to tackle all at once as well. And like being able to then specify the and scope it down is also like super important. So I think being able to like think about the specific use cases is really important for like general interviews too, because when you get tasked with such a high scope, what will end up happening is that potentially the interviewer has like a different idea of where they were going to take it, but then
Yeah.
if you go into like a very deep like subset, then they like I guess they lose their chance to like kind of go into that more like the pointed questions that they were trying to look for. So I think
Hmm.
yeah, I do think that that makes a lot of sense from that aspect. I feel like there's a lot of also user behavior that also affects how YouTube kind of like comes away with their recommendations as well. Like there's definitely like the business impact that you touched on, like just being able to understand what they're ranking for in terms of how they would prioritize videos, and then also just like how recommendations get set up in the feed, because there's that like sidebar that like comes up that you can like click on, and then there's also the ones like that show up at the end of the screen for you to
Yeah.
like pick, and then so it seems like and then also being able to like understand how a user likes or dislikes a video, I think is also important, because it's not as trivial as I think we come to think about it. It's not just the like button, probably. I mean, the like button definitely
Oh
helps,
yeah.
right? But then
I didn't touch on that. I researched about it, didn't forgot to mention, but yeah.
oh yeah. I think there's like it's interesting because the YouTube content creators also try to like brainstorm this, and now that I'm like kind of one myself, like they do
Yeah.
things where like you should like and subscribe, and then obviously if you subscribe to that channel, they'll probably be more likely to bring it up into like their general feed, right? And then if you like it,
Hmm.
but what makes it like what shows it that you actually dislike the video, and I think that's also really interesting because it's like is it people that just kind of like leave after 5 seconds, or is it people that like end up just like passing over it in the recommendations and not clicking on it? But obviously that's
Yeah.
gonna be more due to like the thumbnail, right, than the actual video itself. And so some of like the really interesting parts of it, I think, can get quite complex, which is why I think yeah, I'm not entirely sure. Like in the interviews, I think most of the times they do try to reduce that scope downwards, so then they can just get an idea of your like technical thought behind everything as well. Um,
Yep.
I guess lastly, I have is like, what does one need to know for like a lot of these general like system design type interviews as well? Like, what level of knowledge you have to possess to understand kind of like performance based on serving machine learning models in production, I guess. And does that mean just like like latency in terms of like caching, in terms of being able to like serve up, like a user's features immediately and be able to like recommend it against a bunch of like objects? Or is it just like being able to estimate scale, like and being able to understand like where something might break in the system? Those are like kind of examples, but like, what do you think is important, and like, what do you really need to like study or just need to know to prepare?
um I think the first thing comes to mind is don't spend too much time in the weeds. Namely, like, don't in an interview, unless you're prompted or unless it's obvious, don't or I'll say apparent rather than obvious. Don't spend your time like determining asymptotic runtime of an
Yeah.
operation.
Yeah.
Uh, the real question, I think it's a binary question: is this feasible? Is this not feasible?
Yeah.
So if you can mention that, I feel like I mentioned that in my interview. I was like, this is not feasible to do, so this is how we solve that problem and
Yeah.
still achieve our goal. And this is feasible. Like that kind of detour I took with, combining the users to amortize the time. that's kind of a detour, but I brought it up because I thought it was interesting, and maybe the interviewer will find that interesting too, and be glad that I touched on it. But things like that, I would encourage in general to stay away from, because you're going to spend your time studying things that I think are not relevant. Like it'll be it'll be apparent whether something is, or it's not important if something usually is n log n time or n squared time, but once it gets to 2 to the n time, and you don't have to say that, you just can say it's infeasible.
Gotcha.
Yeah.
So it's more about kind of like estimating general parameters for these things, like being able to say
Hmm.
like this is doable, and like here's a quick explanation why. And it's not like, I don't know, like Kubernetes works like this, and this is like how it works in the background and like
Yeah.
stuff like that, right? Like that kind of stuff is like,
Yeah, not relevant.
yeah, because at the end of the day, someone can implement it and it'll work. You just need to know what it does and how it works, or what comes out of it, basically, right? Yeah,
Yeah, exactly. And you have to define parameters, like what does it do? Are you worried about whether or not it'll scale? Things like that.
yeah,
Um, and if the interviewer is the interviewee, the person talking, being tested, if they're the ones to mention scope first, I think that's a huge win. When I'm giving an interview, and I sometimes have to bring up or scale, not scope. I sometimes have to say, how does this scale? But if the candidate says that before I mention it, that's a huge plus in my book.
gotcha. Okay, cool. Thanks for all your help, Dan.